We'll begin with the 7th and 8th, the facial and vestibulocochlear nerves. As we've seen, these two nerves leave the brainstem just below the pons. Here's the facial, here's the vestibulocochlear. To follow them, we'll look at a dissection of the posterior cranial fossa, in which the cerebellum has been removed. Here's the back of the petrous temporal bone. Here are the facial and vestibulocochlear nerves. This is the vestibulocochlear nerve. This is the facial nerve. Together they pass through this opening, the internal auditory meatus. Here's the internal auditory meatus in the dry skull. It's a short tunnel with 3 openings. The facial nerve passes forwards through this one to enter its own bony tunnel, the facial canal. In the facial canal, the facial nerve has a complex course in the temporal bone, passing round the wall of the tympanic cavity and coming out behind the styloid process here. To get a view of its course, we've removed the front wall of the external auditory meatus along this line. We've also unroofed a small part of the petrous temporal bone here. To represent the facial nerve, we'll add this green wire to the picture. Entering its canal, the facial nerve passes forwards briefly, then makes an abrupt U-turn called the genu and passes backward. To follow it, we'll come round to the outside and look into the tympanic cavity. The facial nerve passes backwards high in the medial wall of the tympanic cavity, above the oval window. It then turns downwards to emerge here at the stylomastoid foramen, just behind the root of the styloid process. On its way through the temporal bone, the facial nerve gives off 3 branches: the greater petrosal nerve, which is an autonomic branch, a branch in the middle ear to the stapedius muscle, and a special branch, the chorda tympani, represented by this wire. The chorda tympani passes upwards on the inside of the tympanic membrane and leaves the cranium here to join the lingual nerve. We've seen already that the chorda tympani transmits taste sensation from the anterior 2/3 of the tongue. Now we'll follow the trunk of the facial nerve. As we saw in the previous tape, the facial nerve passes through the parotid gland. In the dissection we'll look at now, the parotid gland has been completely removed. Here's the external auditory meatus, the sternocleidomastoid muscle, and the posterior belly of the digastric. Here's the styloid process. Here's the trunk of the facial nerve emerging from the stylomastoid foramen here. Now we'll add its branches to the picture. Between them, they supply all the muscles of facial expression. These temporal branches supply the frontalis muscle. These orbital branches supply the muscles around the eye, including orbicularis oculi. These buccal branches supply buccinator, orbicularis oris, and the muscles that move the upper lip. These marginal mandibular branches, which pass just below the body of the mandible, supply the muscles that move the lower lip. They also supply the platysma. In addition to supplying the muscles of facial expression, the facial nerve gives off this branch that supplies the posterior belly of the digastric and the stylohyoid muscle. Now that we've looked at the facial nerve, we'll look very briefly at the 8th cranial nerve, the vestibulocochlear. The vestibulocochlear nerve enters the internal auditory meatus, dividing as it does so into the vestibular and cochlear nerves. The vestibular nerve passes through this opening into the inner ear. The cochlear nerve passes through this one. The 2 nerves transmit our senses of balance and hearing, respectively. Let's move on to look at the last 4 cranial nerves. They're the glossopharyngeal, number 9, the vagus, number 10, the accessory, number 11, and the hypoglossal, number 12. These 4 nerves leave the skull close together. Here are the 9th, 10th, and 11th nerves. The 9th and 10th nerves arise from a line of filaments that emerge from the lateral aspect of the medulla. Here's the glossopharyngeal nerve, the 9th cranial nerve. It's quite small. Below it is the vagus, the 10th nerve, arising by one large root and a line of smaller ones that emerge from the medulla all the way down to here. Below the vagus is the accessory nerve. Its full name is the spinal accessory. It arises from a procession of filaments that emerge from the spinal cord from C1 as far down as C5. The spinal accessory runs upwards through the foramen magnum to join the 9th and 10th nerves. The hypoglossal nerve, the 12th cranial nerve, arises more anteriorly. Here are its filaments converging. The hypoglossal nerve passes through the dura by itself. The 9th, 10th, and 11th nerves pass through the dura together to enter the jugular foramen. Nerves 9, 10, and 11 leave through this part of the jugular foramen. The hypoglossal nerve leaves through this opening, the hypoglossal canal.